I just wanted to share this with you before we get started, because I think these things going into matric are really, really important. So the first thing that I wanted to say to you is, try not to be absent from school. All right, if you're not at school, your teacher cannot teach you. I know that sounds very silly to say that, but it's the truth. If you're not there, you can't be taught, and that means you miss out on valuable examples and information. So make sure that you catch up as quickly as possible. The other thing that is important to remember is that for those of you that are at school, you are attending Watobe in addition to school and not instead of school. So there's no ways that Yolanda and I can cover the content as well as the depth of content that your teachers are going to cover at school with you. So you must make sure that every single day you are in class, you are listening, you're paying attention, you're taking examples. If there are things that you don't understand and you want to ask questions here at Watobe, we will definitely find a way to incorporate your questions and the things that you want to ask into our lessons. But it's very important that you understand that you are going to school and working as hard as you can and coming to Watobe as well. All right. The other tip that I wanted to give you for the year is to try and work as independently as possible. If you have finished a section of work at school, go and look for exam questions. There is so much information available on the internet, in books, in past textbooks, in exam aids, that kind of thing. Try as much as you can to get your hands on other sorts of questions and expose yourself to as many different questions as you can. Don't wait for your teacher at school to give you the work. Go and look for it. That makes a big difference as well. And then the last tip before we jump in and start with quadratic number patterns is make sure that you keep revising your grade 11 work. As I'm sure your teachers have told you, your grade 11 work, not all of it, but a lot of it is tested in matric. And I'll be sure to go through that with you and explain which things specifically you're going to be tested on again and what comes up and what doesn't. But the grade 11 work is seen as the easy work in matric. So these are marks that you should be able to get. So we want to make sure that you get all those easy level 1, level 2, grade 11 questions, and then we can start worrying about how we're going to get 60%, 70%, 80% by accessing the matric work. All right, so the sections that you need to pay particular attention to in grade 11, your functions in paper 1, and from paper 2, your analytical geometry, your trig, and your Euclidean geometry. Okay. Hang on a second, I don't know that working ahead of the curriculum, Pinga, is necessarily what you need to do. But I mean, if you can read up and look at some examples before you go to class, I think that would always be useful. What's important, Pinga, is that you've got to keep up. Don't fall behind. You don't need to work ahead. Don't fall behind. And if you do fall behind, you've got to try and catch up as quickly as you possibly can. Otherwise, the situation ends up snowballing, and eventually you become so overwhelmed with what you have not done and not covered that it becomes impossible to catch up. All right. So yeah, just stay on top of things. You don't have to stay in front, but just stay on top of. Okay, Amina, no, matric is not easier than grade 11. I don't know about other subjects. I don't know what happens with English and Afrikaans and, your other other subjects that are elective, but maths definitely not. Okay. There's some new sections as well. The trig can be quite challenging. The geometry can be quite challenging. So yeah, I wouldn't know. Luci, there's only one, if I pronounce your name correctly. In your calculus section, there is some application type questions at the very end of the calculus section that is difficult, but calculus is not hard. It's lovely. It's really lovely. It's a lovely, lovely, lovely section. So I'm sure you'll enjoy it very much when you get there. Okay. All right, so now that we've done that, let's jump in and go and have a look at quadratic number patterns, which are tested in matric. So if you can get full marks for this, then you know that you are doing okay. All right, I'm going to whip through this very quickly. I think most of you understand how to do this, but I just obviously want to be thorough and just check that we are okay. And then we've got a couple of questions that we can try ourselves as well. Okay, so they've told us that in grade 11, we deal with quadratic number patterns having the general term in the form Tn equals an squared plus bn plus c. If we look at the number pattern on the board, they give us 2, 3, 6, 11. So 2 is the first term, 3 is the second term, 6 is the third term, 11 is the fourth term. They want us to determine the general term or the nth term for this pattern and hence the value of the 42nd term. When they ask you to determine the nth term or the general term, what does that mean? What are they asking you to do, really? When they say to us determine the nth term or the general term, what are they really asking us to work out? Correct, absolutely. So the formula, the nth term, Tn, the rule, yes, absolutely. Yes, 100%. Okay. What it means, okay, nobody said this yet, and that doesn't matter, okay, but what it means is they're asking us essentially to calculate the values of A and B and C. So we're just going to run through that very quickly. Okay, so determining the nth term or the general term means calculate the values of A, B, and C. All right, so let's get the first, the second, the third, and the fourth term on the board. The first thing that we are going to do is work out our pattern of what? What am I doing here when I draw those lines? What am I calculating? Can anybody tell me? My first difference, lovely, absolutely. So my first difference, so 3 minus 2, because it's term 2 minus term 1, and then term 3 minus term 2, term 4 minus term 3. Okay, and these are referred to as my first differences. And my first differences, what is characteristic of my first differences in a quadratic number pattern? So for every number pattern, this characteristic is the same. What would we say that that is? They do have their own pattern. Okay. Are they always odd, Ofense? Are they always odd? Could they be positive? So Melissa says they will have the same difference. Lucci says they don't have a constant difference. Okay, so the quadratic number pattern does not have a constant difference. Okay, the next difference will be the same, correct, Offense? That's right. Okay, so here, these numbers are always linear. So this is always a linear pattern, linear number pattern. So if something is a linear number pattern, it has a constant difference, which is why now if I say 3 minus 1 and get 2, or 5 minus 3 and get 2, this is what's referred to as my second difference. And in a quadratic number pattern, my second difference is always the same value. Okay, so with a quadratic number pattern, you will find, this is the row, the red one, this is the quadratic pattern over here. Okay, the difference is not constant, it is quadratic. But the first difference of the terms is a linear number pattern. 1, 3, 5 is linear because it has a constant difference of 2 in this case. How do I determine the value of A? Which rule do I use to work out what A is equal to? So in other words, this A over here. How am I going to work out what A equals? There we go, Penga, quite right. Oh, Rona's already got the answer there. Well done, Rona, very nice. Okay, so 2a, maybe I should write over here. Okay, so 2a is going to be equal to the first term of our second difference. So a would be equal to 1. What am I going to do to work out b? Rona, if you want to go ahead and do question B, you're very welcome. If this is easy for you, we are going to get into some slightly more challenging questions, but I'm just trying to solve for B and C simultaneously. You don't actually have to solve for B and C simultaneously, Pigelo. Yeah, Katleho, 3a plus b. 3a plus b is correct. So in other words, when we now want to work out the value of b, we say that 3a plus b is equal to the first term of our first difference. So it has to be equal to 1 in this case. All right, good, yes. Okay, so 3 times 1 plus b equals 1, so b is equal to -2, 100%, that's great. And how do we work out what c is equal to? That's it, Misbah, well done. A plus b plus c. All right, so a plus b plus c has to be equal to the first term of our quadratic pattern. Okay, so a is equal to 1. Plus -2 plus c has got to be equal to the first term of our pattern, which is 2. So that means that c is going to be equal to 3 in this case. So let's go and have a look. What did Rona say back there? She said that Tn equals n squared minus 2n plus 3, and we're getting the same answer. Well done, Rona. So Tn equals n squared minus 2n plus 3 is correct. Well done. How would we now calculate? Everybody happy with that?
Yeah, let's do thumbs up, thumbs down when you're
just checking in. Are we a
indicate.
thumbs up? We're all fine.
Yeah.
Okay.
There we go.
Lovely. Right, so now when they ask us to determine the value of the 42nd term, good job, thank you everybody. What would we do? What are they asking us to do here? Okay, so Lucci, what are we making 42? Are we making N42 or are we making TN42? What are they asking us? Correct, fancy, yeah. No, N is equal to 42. Okay, so here, if they want to know the value of the term, of the 42nd term, they're saying to us that N is equal to 42. Work out what Tn is. When they say to us determine which term will equal 1091, then they are saying to us if Tn is 1091, what is N going to be equal to? All right, so in this case here, we are going to work out what Tn is when N is equal to 42. Now, I haven't left myself an awful lot of space here. I didn't do this very well, but what I'm going to do is just, you guys are welcome to take screenshots as well. I'm just going to get rid of that so that we've got space to write. Okay, so here, to finish this off, we're going to work out what term 42 is equal to by subbing 42 into our pattern. So it's going to be 42 squared minus 2 times 42 plus 3. And hopefully we're all getting the same answer for that. Which was the, oopsie, 1683. Did we all get the same answer there? Is this good? Yes, well done. Good job.
Yeah, the same answer, which is nice.
Yeah, so that's a very, what's happening? I'm so glad you've had this aha moment. It's so important to understand the question. And when you read it, the first thing that you should say to yourself with any maths question is, what does this mean? What are they asking me to do? So when they're asking you to calculate the value of the 42nd term, they're implying 42 goes in, what comes out? If they say to you determine which term will equal 1091, they're saying 1091 is a term in the pattern. Which term is it? Okay, which is exactly what we're going to work out now in part B. All right, you guys are on fire. This is brilliant. Well done. What are we going to do in question B? Okay, good. So my first step in question B is to do what, guys? That's it, Wilfred. Well done. Okay, so we're going to take n squared minus 2n plus 3, and we're going to make it equal to 1091. Lovely. And after that, exactly, we're going to solve the quadratic equation. Now, if we choose to do that by using the quadratic formula or by using factorizing, it doesn't matter. What is important, what you must show, right, is this first step over here where you have equated. The second thing that you need to do is get it into, what's it called? There's a special name for it.
Yeah.
The next step is getting it into, that's at standard form. That's at standard form. So it becomes minus 1088. And what must I not leave off here? Equals 0. Remember, we are solving an equation. Okay, so if there is an accuracy on this line and you leave off the equals 0, they're going to take that mark away from you. Okay, so I'm just giving you little tips along the way here about how it gets marked and not just about how to get to the answers. All right, next step. We've got a choice. Either we use the quadratic formula or we can factorize. If we use the quadratic formula, we must show that we have subbed into the quadratic formula. Okay. All too often, what happens with students is you write the quadratic formula on the page, and then you sub in on the calculator, and then you write down your answer, and you end up throwing a mark away. All right, if you use the quadratic formula, you must show that you have subbed into it in any section. Okay, not just here in number patterns, but if you do it in functions, you've got to show that. If you do it in calculus, you've got to show it. So any section, if you sub into the quadratic formula, you must show that. What would you guys prefer to do? Do you want to sub in or do you want to factorize? What would you prefer? Okay, so a lot of you are saying to factorize. That's fine. That's fine. Pinga, if the number's too large, not a problem at all. If you prefer to factorize, that's also okay. If you did go ahead and went and factorized, it is important that you show the step with your brackets in it. Okay, so in other words, you have got to write this. Okay, so here, n minus 34, and then here it's n plus 32 equals 0. Okay, so either you show this, if you want to factorize, don't forget you've got to leave off, you cannot leave off the equals 0. Or your alternative is subbing into the quadratic formula. So n equals negative b, so that's going to be negative 2 plus minus b squared minus 4. A is 1 and C is whatever it is. That's not very good of me. 2 times 1. Okay, so therefore, so you are either going to get a mark for subbing into the quadratic formula, or you're going to get a mark for factorizing. Okay, there would be 1 mark on that line. You pick your poison. Therefore, 2 solutions for n. Either n is equal to 34 or n is equal to negative 32. Okay, so Pinga, it would be difficult to factorize something like this. You've got to think of two numbers that when you multiply them together, the difference between them is 2. So what I would do is start with sort of two fairly large numbers that you think that when you multiply them together would give you what it's try and error. It would be 1088. So maybe you try 28 and 30. Okay, it's too small. Then let's say maybe you try 35 and 37. That's too big. Then you'll be able to then work out what it is. Right? But if you can't, Pinga, don't waste your time. Don't worry about factorizing. Just use the quadratic formula. If you use it correctly, you'll get exactly the same answer. Okay, I see there's another question here about, yeah, n is equal to 34. Correct, Zechovatso. Okay, so it can only be the positive in this case. Why are we disregarding the negative answer? Katleho, I see you want to ask a question. So you ask your question first. Katleho, you're welcome to unmute and ask.
Ma'am, I just wanted to know, how do you use the quadratic formula, ma'am? Because factorizing is quite easy for me, but I'm still struggling with the quadratic formula.
Okay, so with the quadratic formula, Pinga, it's just a case of substitution, right? So just very quickly here, let me just explain this to you, okay? The quadratic formula is on your formula sheet. On your formula sheet, it says x equals negative b plus or minus, and then here it's b squared minus 4ac all over 2a. Sorry, I shouldn't have gone as far as that. It should just be here. Okay, so when they talk about the values of A, B, and C, the value of A, if you recall, was 1. The value of B was negative 2. And the value of C was positive 3. So those are the values that you're substituting in here. So we're not solving for X, we're solving for N. So negative B means negative, B is equal to negative 2. So now I'm going to substitute in negative 2 in place of B. Plus or minus the square root of b, which is negative 2, and I'm squaring it, minus 4 times a is 1, and c in this case is, oh, hang on a second. Sorry, is minus 1088. Sorry, I beg your pardon. I went back to this, but it's not that one that we're factorizing. Sorry, this is one of the limitations of working online. Right, this is what we're trying to factorize over there. So, sorry, A is equal to negative 1, B is equal to negative 2, and C is equal to negative 1088. Okay, Pinga. So now I'm going to take those values and I'm going to substitute them in here all over 2A. So A was equal to 1. Okay, and then you can pop that into your calculator and you'll get 2 answers. Okay, there we go. So Rona, you're on the right track here. Position can't be negative. The trick is to make sure they always have the same difference. Yeah. You can't have a negative position number. Exactly. All right, so we are counting its position in the pattern. All right, so you can't have position number negative 32. All right, so it's either position 1, position 2, position 3, whatever the case is. So n has to be a natural number, a counting number. Are we all good there? Are we happy to move on? Thumbs ups? All fine? Good.
Oh, fine, guys. That's really good.
Do we want to try something that's a little bit more difficult? How are you guys feeling? I just don't want... Okay, all right. So Cool. So what we're going to do, I'm then going to leave this. I'm not going to get you to do that. We're going to go straight to an exam question, which is down here. And what we could potentially do this lesson as well is have a look at the slightly more difficult questions as well, if you guys are up for a challenge. All right, so is this big enough? Can everybody see this okay? Yolanda, is it big enough?
Yes, on my side it is clear. I think everyone should be able to see it as a little bit small, but we can see.
Okay, that's fine. So someone's just saying, please zoom in. I'm going to do that. There we go. That should be big enough now. Okay, so this is a typical exam type question. What you will see when you look at this is that the first 3 questions are standard questions, writing down the next term of the pattern, determining the nth term, which term of the pattern will have a value of 5 or 8. So these are your level 1 and level 2 type questions that everybody should be able to get. So what I'm going to do is, this is 2, that's 6, this is 10 marks over here. So what I'm going to do is I'm going to give you, I don't know if we'll need as much as 10 minutes. You could probably do it a little bit faster than that. Work out 4.1, 4.2, 4.3. If there are people that are finished, so Rona, you were a fast finisher, you're welcome to try 4.4 and then 4.4. Unfortunately, we need the answers from 1 and 2 and 3 to do 4 and 5. Okay, so let's just get those. We'll check that they're okay, and then we can jump into 4 and 5. So I'm going to let you guys work this out on your own, okay? 1, 2, and 3, and then we're going to get started on 4 and 5.
Let's do this, guys. Let's go. Let's see. Remember, even if you feel a little bit lost, just try your best. Try to do what you have understood so far. Will definitely put you up to full speed if you didn't understand. You guys are really doing well. Let's go. Let's go. We can do this. You're allowed to ask if you get stuck somewhere or something. I would like to believe that everything is going smoothly for everyone, since y'all are quiet and working nicely.
Okay, so Tony, you've said 76. I presume that's your answer for 4.1. Okay, Pigelo, thank you for sharing your answers with us. And Tony saying, okay, so you guys have got the same answer for your nth term. Good stuff. Cool, yes, 100% correct, that is right. Okay, so now you've been able to do that. You should be able to do 4.3 pretty quickly. Yes, good job, everyone. Absolutely, Pinga. Absolutely. Okay, so if your second difference is negative, then you must make 2a equal to whatever that is, including the negative. And then that will become the coefficient of your n squared term. Okay. That's it. Well done, Phoebe. Lemochang, that's good. Keep going. That's it. Well done. Yes, good job, everybody. Nice, Katlego. Well done. Good. You're ready to move on to 4.3 now. Okay, good job. Well done.
Wow, they're really getting this. Well done.
Good, NC. Good, Lemochang. Okay, so for those of you that have managed to do 4.3, you can now start thinking about 4.4 and 4.5. That's going to be our challenge. I'm just going to give, okay, offense. What I want you to do is you can either DM me or Yolanda and tell us what did you get as your nth term. What did you get as your nth term, offense? Tony, yeah, see, offense is saying the same thing. Okay, so now Tony, let me just message you, Tony.
Molefe, if that hand is up to ask a question, you can unmute yourself and ask.
Good evening to everyone. I wanted to ask for 4.3. I did the whole calculating for the quadratic equation and I got two answers. How do I determine which one is the correct one for the sequence?
Okay, which two answers did you get?
I got a 3 and negative 23.
So you got 3 and so you got 3 or negative 23.
Yeah. Yeah.
Okay. Now let's say that both of those answers are in fact correct. Okay. When we are talking about n is our input. So in other words, it is our position in the pattern. So n goes in and tn comes out essentially. So the first term in the pattern is 244. The second term in the pattern is 193. The third term in the pattern is 148. So is it possible to have pattern number minus 23? It's not. Okay,
No,
because exactly. Okay, because we can't have position minus 23. We start counting at 1. So it's either position 1, position 2, position 3. So in this situation over here, that would be the correct answer because it has to be the natural one. But I'm not sure that that is
if my answers are wrong.
exactly.
Or maybe it's
Yeah,
the
so
other
it was
way
supposed to be the
around.
other way around. It was supposed to be the other way around. Okay,
Yes,
so it
ma'am.
was negative 3 or 23, so it would have been position 23.
Yes, ma'am.
Okay,
Thank you.
no problem. It's a pleasure. All right, is there anybody else who are not good, Boucher? That's great. Has everybody been able to do up to 4.3? Can we look at the answers? Miss Bar, yes. Still busy with 4.2. Okay. And see, you've got a decimal 4.3. All right. So LS Bocello, just carry on working. That's fine. That's not a problem. Offense, let's see if we can fix your mistake. Okay. So this is what you should have had. Let's just move this down here and make this a little bit bigger. Okay. So offense, you should have got, this is your nth term over here. Can you see that? Is it big enough? So a lot of you were putting that into the chat, and that is indeed correct. Okay, Amina. Have you got this? So Amina, look here. I'm going to change the color of my highlighter. Okay, so I'm changing it to turquoise. There's your A plus B plus C equals the first term of the quadratic pattern. Have you got that same line in your working, Amina? A plus B plus C. Okay, so now, all right, Jody, well done. We'll go and see if we can, if that is correct. Well done. I will show you the answers now. Okay, good job. Jody, see if you can do question 4.5. Just as a bit of a challenge. Okay, so Fencer, you found your mistake. And then here, they've asked us which term in the pattern is equal to 508. So there's a mark for equating, a mark for standard form. See how they haven't left off the equals 0. Sorry, here's their standard form over there, not that one. A mark for factorizing or using the quadratic formula. It's just not in our solution. And then for choosing that n is equal to 23 and not 3. Okay, is everybody all right with 4.1 to 4.3? These are the basics. We've got to make sure that we can do that. Thumbs ups, emojis, are we okay? You want to see the questions? Sure, Rona, I'm going to go back up here again. There we go. Are we all okay?
Oh my guys.
Okay, I mean, you saw your mistake, you didn't make 50. It's always little things like, often little things like that. Hey, Amina, I know I made a mistake in our previous lesson. Also, I had something that was positive and it should have been negative or the other way around. Yeah, me too, Pinga. I also make silly mistakes with signs. Okay, good, Buffet. Okay, so let's try and do question 4.4 at the very least. I don't know if we're going to have time to do it all. I so wish our lessons were longer than just an hour, but anyway, they're not, and that's just the way it is. So the question in 4.4 is between which two consecutive terms of the quadratic pattern will the first difference be 453? Anybody got any ideas as to how we would even begin to do that? Rona, what would you do?
Can you hear me first of all?
Yes, we can. Yes.
Loud and
Okay.
clear.
The first thing you need to do is remember the rule about quadratic patterns, which is that the first difference forms an arithmetic sequence. So knowing that, then you use the formula for arithmetic sequence to find which term will give us the answer 453. So I did that calculation and I got that the answer is n is equals to 85. But from here, I'm stuck. I don't know where to go. But yeah, that's the first step.
Okay. All right. Rona, I love what you've said there. What I want to point out to you and to everybody else, and you guys have really done exceptional work this evening. That's great. Is look here at this, and I'm just going to write on the answers here rather than redo this again. Okay. This is your quadratic pattern. Okay. The 244, the 193, the 148, the 109. Here is your first term, here is your second term, here is your third term, here is your fourth term. So the difference between the second and the first term is minus 51. That is the first term of the first difference. So in other words, the first term of the first difference lies between term 1 and term 2 of the quadratic pattern. And term 2 lies between term 2 and term 3 of the quadratic pattern. And term 3 of the first differences lies between term 3 and term 4. So when they say to us, between which two consecutive terms of the quadratic pattern will the first difference be 453, we will know because we will see if it is pattern, if it ends up being that the difference over here is 493, it's going to lie between term whatever. So here, this, if this is, for example, and it's not, but let's say this is term 90, then this will have to be term 91, because this would be term 90 in the first differences. Okay, so this is how we're going to be able to work out between which two. Okay, so a way of doing this, is more than one way to do this, but the easiest way for you to do this is to work out the pattern of the first differences. So in other words, work out the linear number pattern. So here we are going from, let's just get it down on the side, from -51 to -45 to -39. We know each time our constant difference is 6. Do you remember in grade 8, now in matric you're going to learn a new formula, but in grade 8 your teacher would have taught you to take that difference and make it your multiplier. So all linear number patterns take the form Tn equals Bn plus C. So this B over here, that's going to be your your constant difference. So I'm going to take the 6 and make it 6n plus C. And now if I want to work out what C is, this is the first term, this is the second term, this is the third term. That's my n, that's my Tn. So what I can do is I can say when -51 comes out and 1 goes in, what is the value of C? So I'm going to take that 6 over to the other side, and that would give me -57 as my answer. So -51, take away 6, because the 6 gone over to the other side gives us -57. So that means that the pattern describing our first differences is the pattern Tn equals 6n minus 57. I can now make that equal to 453, because 453 is one of our first differences, isn't it? It's just much further down in the pattern. So that's going to be our Tn. So I'm going to take 6n minus 57 and I'm going to make it equal to 453. I'm going to take the 57 over to the other side. And if I've got 453 and I add 57, that's going to leave me with 510. And now I'm going to divide both sides by 6. And that gives me 85. Okay, so in other words, what we have now calculated is that way down here, all the way down here, between term 85 and 86, this is supposed to be 86, between term 85 and 86, the first difference is 493. Does that make sense to everybody? That's it, exactly, Jody, exactly,
Well done,
exactly. Okay, you are going to learn in matric this year, you are going to learn a quicker way of doing what I've showed you over here. This is the baby way of doing it. They're going to show you something else this year, but you wouldn't know how to do that just yet. Oh goodness, is it poll time already? Okay.
Yes,
Go for it.
We're right out of time, but okay. If you'll just please attend to the poll for us, like this, we will know what we need to do when we see you on Thursday. And thank you so much to everyone. And thank you for participating. Y'all are awesome. And today we have learned, including me, we have learned quite a few things. So I'm happy. Let's see if it gets to 100%.
Rona, you wanted to ask a question? You're welcome to go ahead if you want to unmute and ask.
Yeah, I wanted to ask if like the shorter way of doing it involves like T3 is equals to A plus 2D, and then that's for arithmetic sequence, and then the other one
Correct.
is for T.
I seem to have lost you, Rona. I don't know if you can still hear me, but what you would be using here would be Tn equals A plus N minus 1D. It's the same thing. But they will teach you this year. That is your term formula for an arithmetic sequence. So yeah, you could have done it. Yeah, absolutely. You can do it that way as well.
Okay, thank you.
Okay. Rona, did you manage to do question 4.5?
No, I didn't.
Okay, so Amina's asking me to show you the question. Here it is. There's 4.5. What I'm also going to do, here it is, Amina. There's 4.5, and anybody else that's interested. It asks you to show that all the terms of the quadratic pattern are positive. So I'm going to show you the question, and then what I'm going to do is I'm going to go over and I'm going to show you the answer as well, so that if you want to come back and watch this video at a later stage, you can see how the question was answered. Okay, and then at least you've hopefully been able to challenge yourself with that as well. Okay, matrix. So there's 4.4. So I'm just going to show you what they've done here. You can see here, Rona, that they've used that new method, which you would obviously know at the end of matric. And then here's question 4.5 for those of you that would like to. Let me just move that out the way if you wanted to come back. What I can always do is next week, I can start with question 4.5 because we'll all have this information in front of us. And then I'll be able to come back here and explain to you what they were talking about. Okay. All right, there we go. Wow, I can't believe that's a whole hour gone. That's crazy.
Yeah, it goes so fast.
Yes, Wilfred, this is grade 11 work. So yes, this is grade 11 work that you need for matric. It's going to be questioned in matric as well. 4.1. Oh, Amina, that's so kind of you. Thank you so much. I'm so glad it makes sense to you. That's wonderful. Thank you. Yes, Melissa, you should, if your school is working according to the ATP, you should be starting with sequences and series. Okay. It's a pleasure, Boucher.